Let's look at the same system again, and this time I say what I want to do is I want to do V out, and my V out I want it to be equal to an integration of this signal of V1 from, let's say, time t1 to t2. Okay, so I just want to integrate. I want the integration of the signal. Now, how do I do this operation? Again, if you really think if you think about it for a moment, I'm sure this is not as difficult as it sounds, right? Because if I have this analog signal here, let's say this signal, and I'm saying I want to integrate it from time t1 to t2, and now what I do is I take the samples of this signal, let's say at some fixed time interval. Okay, and now I say, okay, what does this integration represent between in this time? It's basically an addition of the signal, right? If I have discrete time points and not a continuous signal, then integration can be replaced with basically a summation. Okay, so what I want to do in the microcontroller is basically a sum. So I want to add the v1, and of course when I'm writing v1 here, I mean the digital representation of v1. uh, just in case you haven't noticed it, I'm writing in blue the digital signals and uh, writing the analog signals in black, just so that there's a distinction here. So the first step, again, as before, is that this analog signal V1 is converted into a digital signal. And this digital signal is basically going to be an array of signals, right? An array of numbers. So it's going to be an array of numbers, and there are going to be some numbers out here. And what you want to do in the microcontroller, instead of integration, is add all these numbers up. And once you add that and add those numbers up, you will convert that into a digital to analog value, and you will get V out, which corresponds to that integration. So uh, all these operations, what they have in common is that the subtraction before and other processings that you can do in this way are just basically working on the time domain. So you just take the samples of the signal and do the processing on individual parts of the signal, individual what should I say, samples of the signal, and you get your output. Sometimes you may have to combine these individual samples in some way. For example, like what we did here. Um, and once you do this processing, you just convert it into an analog value, and you have the analog, you have the signal that is digitally processed, but it has the output as the same as that of the analog circuit. Okay. Now, in the next video, what I want to do is I want to look at frequency processing of these signals. So right now we have done time domain processing of the signal. I want to see what happens when you want to do, say, a filtering in at the analog domain.